All right. Hello? Cool. Okay. Can everybody hear me? Everything's fine. Sweet. Okay. Hi, everyone. So my name is Carmel Hinks. I'm a software engineer from Atlassian, and I'm here today to be speaking to you about how we at Atlassian were able to adopt a bit more of an iterative approach to the definition and maintenance of our metrics, dashboards, and monitors. But before I get started, I would actually like to do that super annoying thing and make everybody please raise one hand. One, yep, okay, keep a hand up, keep it up. So keep your hands up if you're on a team that runs or maintains some kind of application. Okay, sick. Keep your hands up if you know that the dashboards and monitors for that application are all up to date and actually useful. Okay, like that's not bad. We have 3 people left. Okay, never mind. You can keep your hands up. I have more questions. Keep your hands up if you know that within the past week, are you guys the only ones? Yeah. Your service has hit all of its SLOs. Your service has hit all of its SLOs. Okay, let's go with no. Okay, that's cool. If you guys put your hands down early, I'm actually pretty surprised. Normally people sort of put their hands down after that second question, so you guys nailed it. But we all, kind of most of us in Atlassian would have put our hands down after that second question. And that's because in the past few years, we've adopted the you build it, you run it methodology. So for anyone who's not already familiar with that, I'm sure most of you are, but it's just the idea that if you or your team build some kind of application, it's on you to not just maintain the code for that application, but also all of the operational concerns that come with it. And that's fine, but as software engineers, we weren't super used to having to do that. And so we made a few mistakes along the way, and there was a bit of a learning curve involved. And one of the mistakes that we realized we were making was that we had a bit of a tendency to set and forget our operational resources. So basically, we would sit down, try to define everything up front, get it completely right, and then put it down and never look at it again until something fundamentally shit itself. And as you can imagine, that came with a few negative side effects, which we'll cover throughout this presentation. But thankfully, that was actually in the past. And we've managed to come a long way since then, where we've moved towards a much more agile and iterative approach to the definition and maintenance of all of these things. And we've learnt a lot along the way. And so I'm here today to share with you some of the key learnings that we've made throughout that transition, so that if you were to all hear those questions again in 6 months' time, you would all have your hands up at the end. So just to give you an overview of what we're going to be speaking about today, I'm going to start off with a few explanations just to make sure everyone's on the same page. And I'll then tell you a bit of a story to help set some context. We'll then take the rest of this presentation to take a deeper dive into how you can decide what to measure, how you can verify that what you're measuring is correct, and how you can help your team keep up to date with change. And then, of course, we'll finish up with a summary at the end. But what are we actually talking about today? Well, throughout this presentation, you're going to hear 3 terms come up pretty regularly, and that's metrics, dashboards, and monitors. And so it's pretty important we're all on the same page of what that actually means. So when we're talking about a metric, we're talking about a measure of a software characteristic. So basically, you've taken your application, you've instrumented it in some way, and you've started pushing out some kind of measurements. But a few of you might be thinking, isn't that an analytic? And I wanted to call this out because when I started coming up with definitions for these things and talking to my colleagues at work, I realized the difference between these two is a very philosophical discussion. And so for the purpose of this presentation, we'll be saying that a metric is something that our systems are doing. So with Jira, for example, we might perform a bunch of database operations to view an issue. So a metric would be how long we spent performing those database operations. Whereas an analytic is something that our users are doing. So how many times was that issue viewed? And that would be an analytic. So if we can see metrics as essentially a collection of data that demonstrate what our systems are doing, a dashboard is just a visualization of that data. And this can be done in a variety of different ways. You can chart it over time, you can aggregate it into a single value, you can get lots of different metrics and put them on a table. It doesn't really matter. If you've taken some metrics and you visualize them, you probably have some form of dashboard. And finally, we have monitors. So monitors are an alert that have been defined against one or more of your metrics. Basically, they're a way to monitor that your application is still behaving in the way that you expect. And this can be fairly mild. So maybe you'll send an instant message notification to let your devs know that something is wrong. Or it can be a lot more aggressive, where you start sending an alert to the person who's on call. And all three of these things come in a variety of different forms. And the most common you'll hear about would be analytical, strategic, and operational. But for the purpose of this presentation, we're going to be focusing on those that relate to operational health. And the idea here is that an application with good operational health will help you figure out what went wrong, when that thing went wrong, and why the thing went wrong. Or ideally, shortly after the thing actually went wrong. And so, on that note, I'm going to tell you a bit of a story about a project that I've recently worked on in Atlassian. And that's because the project is very relevant to the content that we'll be covering today. But I want you to, I guess, brace yourselves a little bit, because we do have to cover a little bit about how the Atlassian cloud infrastructure works, but it's fine. So in Atlassian, we run and maintain our cloud infrastructure on a multi-tenant architecture. And this just means that a single running application can serve many different customers. So one of the key components within a multi-tenant architecture is the ability to share resources. So if I were to have my Jira, and that Jira was made up of some application nodes, a database, and a queue, in order for that Jira to be multi-tenant, I would need to make sure that it was safe for the various different customers consuming that Jira to safely share the resources without seeing each other's data and all sorts of bad stuff. So that's fine, but at Atlassian, we actually have hundreds of thousands of customers, and they're located all over the world. And so having one big massive pool of resources for everybody to consume from starts raising a few questions with regards to things such as cross-region latency, or scale, or progressive rollouts, and all sorts of other stuff. And so we don't have just one big enormous pool of resources, but rather lots of smaller little pools that we call shards. So you can see a shard as essentially a collection of resources that are used to run one of our products. And the idea is that a shard will service a subset of our customer base. So a customer is allocated to a shard when they sign up with us. So they'll come in, they'll ask us for a product, we hand that request over to the provisioning pipeline, a bunch of magic happens, and then the customer ends up on a shard. So if we were to open that magic up just a little bit, we see that it's actually just a collection of microservices all doing various different things. And one of those microservices is called the shard service. So the sole purpose of the shard service is to select a suitable shard for a customer at provisioning time. And a suitable shard is based on two factors. The first is geographic location. So is the shard physically near to the customer who's making a request? We don't really want customers located in Australia with all of their resources in Europe, because that's kind of needlessly slow. We may as well just put those resources in Australia. The second thing that the shard service considers is whether or not those shards can actually take on more customers. And in order to answer this second question, the shard service needs to keep track of the capacity of all the shards at any point in time. But I mentioned before that shards are made up of a collection of resources, and theoretically, any one of those resources could begin to be strained. And so the shard service doesn't just look at one metric, but rather many different metrics, all of which come from the shards to represent the various different capacities of all of the resources within those shards. It can then take the limiting factor, and it uses that to denote the overall capacity of the shard. Cool. So now you will understand how Atlassian Cloud Infrastructure works, but you'd be forgiven for wondering why any of that was relevant. And the reason I wanted to share that with you today is because at the end of the day, the primary purpose of the shard service was to collect and analyze metrics. And that meant that this project was all about metrics, monitors, and dashboards. And during my time working on it, I learned 3 big lessons. The first is that understanding what to measure is pretty freaking hard. And what worked today, from an operational point of view, was not necessarily going to work tomorrow. And keeping everything and everyone up to date was also pretty hard. And that's kind of the content of this entire presentation. And so throughout this talk, we're going to be referring back to the shard service to pull some examples to help explain some of the concepts that we'll be covering today. So on that note, we'll start diving into how you can decide what to measure. In the words of Sherlock Holmes, it is a capital mistake to theorize before one has data. And he was very clearly talking about software engineering when he says that, and so it's quite obvious that we need to go and get ourselves some metrics. But that then lends to the question of what metrics do you collect? And it turns out that's not the easiest question to answer, especially in the beginning of development, because you don't really know what your application is going to do or how it's going to fail. And we found that this uncertainty in the beginning of the project would lead to a bunch of temptations. The first was that we figured maybe we can just measure nothing. And that doesn't sound awesome, but it kind of feels logical during development because nobody is actually using your application yet. So you kind of figure maybe it's not a big deal if we just kind of do literally nothing, and then right at the end we add a bunch of metrics and roll that out. And that's fine, but it would mean that your metrics aren't going to be verified before going live. It's kind of like shipping a dev version of your operational resources to your customer. And that isn't great because it means that your first incident is probably going to suck because you're probably not collecting the right things or using them in the right way. And this isn't even a solution, it's just a deferral of the problem, so this doesn't really even count. Maybe we could measure everything. We can instrument everything that we can think of just in case. And oh my God, that's amazing because now we have 100% visibility of our application all the time. But again, few trade-offs. To begin with, it's expensive, both in time spent doing that instrumentation, but also money because it costs a lot to collect and store that much data, especially in a way that's searchable and aggregatable. It creates a lot of noise, and it becomes very difficult to differentiate what's important from what's unrelated from what's a red herring. And it really doesn't scale. So if you start telling your developers to remember all the metrics when you're collecting all the metrics, that gets pretty old pretty fast. And so that kind of sucks, right? You can't do nothing and you can't do everything, so there has to be some kind of in-between. Well, we figured maybe we can just measure the things that come out of the box. And to be honest, that sounded pretty good to us because at Atlassian we use AWS. So we get heaps of stuff from CloudWatch. And we use Java. There's all sorts of cool tools to give us stuff about our JVM. And that gives us tons of metrics. And so we switched those on and we created this awesome dashboard where we've got some cool stuff like CPU, we've got some latency, we've got some network. Looks pretty good. And we needed a monitor. So, you know, we don't really want CPU sitting at over 80% for more than 5 minutes because that sounds really, really bad and we should definitely alert if that happens. And yeah, that's it. So operational maturity has been reached and we can now move on with development. And that's what we did, and we rolled out and everything was awesome. But then we started to receive an alert from one of the other services in the provisioning pipeline. And this alert was telling us that provisioning had started to fail because the shard service had stopped returning any suitable shards. And that was pretty weird because when we looked at the dashboard, shard service was looking pretty healthy. But so we looked further into the problem, and what we found out was that the shards were full. There were no suitable shards for the shard service to return. And thankfully, that was a pretty easy problem for us to resolve, but it really emphasized that we were looking at the wrong things. And so we decided to take a step back. And we really asked ourselves what questions we wanted to be able to answer with our operational resources. And we found that answering this also wasn't super easy. And so what we needed to do was have a really good understanding of the roles and responsibilities of our application. So in the shard services case, we remembered we needed the shard service because we had to perform the selection of a suitable shard based on geographic location and dynamic capacity metrics. And with this in hand, we could then start thinking about what it looked like when our service's ability to fulfill those roles and responsibilities started to degrade. So the shard service, for example, was a synchronous HTTP-facing service. And so that led to a few fairly obvious things that could go wrong. Maybe the requests slow down significantly, or they're accepted, but then they fail. Or maybe it just starts rejecting requests altogether. That all sucks, and we definitely don't want any of it to happen, but it's really not specific to the shard service. Any other HTTP-facing service probably has similar concerns. But then we started to look at a few things that were less obvious. Maybe there were no suitable shards. Incorrect shards had started to be selected. Or maybe there was not enough data to make any reasonable decisions. And this really emphasized the difference between infrastructure metrics and application metrics, where a useful infrastructure metric is something that's tied to a component within your tech stack. So you could have 10 different engineers and they're all using the exact same queue, but they're from completely different companies with completely different applications. But every single one of them probably cares when that queue becomes super congested. But then we have application metrics, where a useful application metric is something that's tied to the domain of your application, and only you can know what that is. And so we found that in order to have a good and holistic view of our application's health, we really needed both. And so we continued to capture our infrastructure metrics, but then we also started to push out custom application metrics as well. So one example of that is the capacity of our shards. So this was the capacity from the shard services point of view that it would push out as a metric from the shard service. We also would admit the number of errors that we were logging and the reasons we were selecting shards. So with that, we were able to create 3 dashboards. One to give us a snapshot overview of the capacity of all of our shards at any point in time. Another to show us why and how we were selecting shards. And then we still had our infrastructure dashboard, because at the end of the day, that was still really important information. We also revised our monitors. So we realized we didn't give a shit about CPU, because the shard service was not a CPU-intense application. And so seeing high CPU was not necessarily indicative of a performance degradation. But we did care if shard or region capacity became exhausted, or if we saw a surge in errors being logged by our application. And so how can you decide what to measure? Well, we found that we really needed a good understanding of what questions we wanted to be able to answer with our operational resources. And we found that a good bit of structure to help us do that was ask ourselves why our service existed in the first place. So what are your service's roles and responsibilities? With that, you can ask yourself what it looks like when your service cannot fulfill those roles and responsibilities. And then you can ask yourselves how you can verify whether or not such a degradation has occurred. Okay, so we've selected what to measure, but how can you then verify that you've collected the right things or used them in the right way? We found that at this point, it was pretty tempting to think we got it all right because we just spent all this time answering these difficult questions. But what we noticed is that as time went on, a few things started to happen. Things changed because, you know, when there's agile, iterative environment and like our application's evolving all the time and like that's awesome, but it meant from an operational point of view that what was going to work today might not necessarily work tomorrow. So one example of that was that we ran all of our services behind an elastic load balancer, which was just kind of the load balancer at the time from AWS. And from the load balancer, we got a ton of important metrics. But then AWS rolled out the application load balancer, which was meant to be a lot better, and so we switched over all our services. But with that came completely different metrics. And we knew that, so we went around and we updated all of our dashboards and monitors. But my team didn't just maintain the shard service. We maintained 13 highly critical platform applications, and so we had a ton of dashboards and monitors. And when we were going through and updating them, we missed a few places. So everywhere we missed was completely broken. We started to receive a lot of alerts which were either not useful or just not actionable. So one example of that was my team would get an alert every time a Jira shard filled up. And that was a problem because we were a platform team and we couldn't do anything about a Jira shard filling up. Only Jira could do something about that. And so we would receive alerts that we couldn't actually resolve. And finally, we realized that we had 2 states that our application could be in: completely fine or on fire. Basically, we would never look at our operational resources until something completely exploded. And that was a problem because we defined a service level objective, or SLO, against our application. So for anyone who's not familiar with this, an SLO is just the level of service that you're willing to commit to offer. So it kind of comes down to how important your application is. So one example of that is availability. And you can say, I'm going to commit to having 99.99% of my requests succeed. If you were to make that claim, try to think about how you would verify that you were actually living up to it. You probably have to look at some kind of metric or something, right? But we weren't doing that. We were treating lack of alerts as meeting SLO. And it turns out we were not the only team who were doing this. There were teams all across Atlassian who were experiencing similar pitfalls to us. And one of those teams was a very large team over in Austin. And they were running 70 different microservices. And so from an operational point of view, it got a bit full on. So eventually, one of the members of that team decided, all right, that's enough. And they introduced this crazy process to Atlassian called TechOps. So TechOps is this super crazy idea that you should have a process dedicated to regularly reviewing, discussing, and iterating on operational health. And it's worth pointing out, we did not invent TechOps at Atlassian. This is something that's been around for quite some time with other companies, such as AWS. But within this particular team, they executed TechOps in 5 steps. The first is that they would sit down and develop some measurable goals that they wanted to work towards with respect to operational health. They would then go and get a bunch of data to track in how they were progressing in reaching those goals. That data was then used to prepare a report. So a typical example of a TechOps report would include things such as a log of all of the alerts from that week, a ticker across for whether each service had met its goals, and a summary of all of the notable anomalies and events. At the end of the week, they would then sit down and discuss the report with their team. And during this time, it was expected that the team would raise questions and identify actions that they wanted addressed prior to the next meeting. And they did this every single week, and they evolved the process to suit their team as they went. And they found that this was actually very successful, and they found their alerts reduced, their alerts were more meaningful, their service was more reliable, and so they rolled this process out company-wide. And we were one of the many teams who decided that this sounded like a pretty good idea. So we sat down and defined a goal. And at that time, we wanted to reduce the number of noisy alerts that we had received because it was getting kind of out of hand. And getting the data for that is pretty easy. Just look at the alerts that you've received that week. And just, I guess, FYI, we'd received 87 low priority alerts that week, and this was in addition to all our high priority stuff. But of those 87, approximately 80% of them, I would say, we ignored because they weren't actually very useful. So that wasn't great, but it gave us something to work with. So we took all of those alerts and we put them on a report. And in addition to the alerts, we also put a screenshot of all of our dashboards at a point in time, as well as a list of all of the incidents that had occurred with all the information. And at the end of the week, we sat down and had a discussion with our team. And during this time, we noticed some really, really good questions come up. We would ask ourselves how actionable each of those alerts were. So we literally went through all of the alerts on that page. We sort of did that in kind of stages. But we would ask ourselves whether or not each of the alerts was meaningful and whether or not we could change it to make it more beneficial. We ask ourselves how discoverable all of our resources were. So during an incident, did the engineer feel as though they could quickly and easily find everything that they needed? Or were they searching for dashboards that we didn't have, or they were confused by what a monitor meant or whatever? And then we would ask ourselves how useful all of our stuff was. So did we have things that nobody was ever looking at? And conversely, did we have blind spots? And in having these conversations, we found that we were able to identify about 5 or 6 actions every meeting, and we were fairly strict in having them addressed. And the data kind of spoke for itself. So here we see a real graph of the number of alerts that we'd received over time during the first 21 weeks of TechOps. And we found that when we did receive alerts, it didn't necessarily mean that we were going to completely stop receiving them. It just meant that when we did receive something, it actually meant something useful. And over time as well, we found that our application just became a lot more reliable. This is another case as well of another team seeing a massive increase in reliability over time, and also another seeing a big decrease in alerts, which they've both attributed to TechOps. And so how can you verify that you're measuring the right things? Well, you kind of need to review those things, and not just once, but all the freaking time. It turns out operational health is not a one-time thing. and it's something that constantly needs to be reviewed and iterated on. All right, so we've figured out what to measure, and now we've got this awesome process in place to make sure that we're still measuring the right things. But we found that in rolling this out, we started to experience a lot of change because now we were iterative and things were improving all the time, and that's awesome. But it would mean that sometimes somebody would go and define the new amazing dashboard, but you had no idea what it was even called. Or somebody would go and update the threshold to a monitor and you had no idea that change had happened, so the alert that you received tomorrow was going to be completely different to the one that you received a couple of days ago, even though it was called the same thing. And so in this section, we'll just speak about how my team tried to be a little bit more proactive in keeping up with this change. In the beginning of this presentation, I showed you this diagram where the shard service looks at a variety of different metrics, takes a limiting factor, and uses that to denote the overall capacity of the shard. Now, it turns out figuring out what metrics the shard service should look at in the first place was a bit of a problem in itself. Because I mentioned before, there was lots of different resources, and resources come with a ton of metrics. So we weren't really sure what metrics were going to be indicative of capacity. And so in the beginning, we tried to go with something super broad, which was busyness. So the idea with busyness is that every time something would happen in a product, we would fire an event, so like a customer event. And the shard service would consume all of those events. So the theory here is that more events would mean greater busyness, and greater busyness would mean greater resource utilization. And that was actually pretty good, right up until we overloaded a database. And that was because sometimes a single event would become a huge database query, we had a few too many of those, and then the whole thing went down. But that's okay, because now we had a good idea of what metrics to look at in the database. So we started pushing out database metrics as well. And again, was going pretty well, right up until a shard went down. So the shard service is looking at this nice little empty shard over there and sending all the customers to it. It's never going to work, but it looked pretty empty. So we figured, okay, no worries. We'll start pushing out events every time a provisioning failure occurs. And if we see a big increase in failures, something's probably gone wrong and we're going to back off for a little bit. And so on and so forth. So we basically would add a metric, have an incident, add a metric, have an incident, and that kept going until things kind of stabilized. So why is this related to operational health? Well, earlier on I showed you this diagram, dashboard, where down the bottom we see all these different panels. And that's actually a panel per metric that we had defined. So every time we added a new metric, we had to go to the UI and make a manual change to add these new metrics and these new panels. And that kind of sucked because it was pretty slow and pretty prone to error. Because you would go in and you would sort of click the wrong environment or the wrong service or the wrong aggregation type, and it would just be completely wrong. But the biggest problem, it was so easy to forget. Because you would sort of make your change in your application with your new metric and put that up for peer review, and someone would be like, hey, don't forget to update the dashboards, and you'd be like, yeah, obviously, and then like 20 other things will happen, and you completely forget. And so what we started doing was looking for some ways to reduce that. And what we identified was that we had a massive separation between our application and our operational resources, where our application was this beautiful thing, and we cared for it really nicely, and we looked after it all the time and reviewed it. And then operational resources kind of lived over here. And we sort of looked at them sometimes during incidents and during tech ops, but no one really reviewed them that regularly, you know, like not in the same way as our application. And so we started to look for some ways that we could reduce that gap. And one of the easiest things we figured to do was, okay, let's just export all of the operational resources into code. And that meant that we could take that code and we could put it alongside the rest of our application. And then we also updated our build pipeline so that every time we were to make a change, we would take that code and push it out into the various different tooling that we had internally. And so just a quick call out here as well, a question I've had a couple times is how we actually did this. So within Atlassian, for example, we use Splunk very heavily. And Splunk has an export API, which literally dumps everything as XML, and you can store that XML in your application, and then it has an import API of the same XML, so you can make changes and import it that way. And we found that there was an enormous amount of benefit that came with this change, because it meant that all of a sudden, operational resources were now front of mind. They were no longer the separate thing that kind of lived over here, but actually part of our application and part of our definition of done. having everything in code meant that it was suddenly part of our Git lifecycle. So all of a sudden, operational resources were being reviewed. And when something went wrong, we could roll it back. And it came with the added benefit of making everything much more discoverable, because now everything was defined in one place. And once again, we were not the only team who were making these changes. There were teams all across Atlassian who had started to export their dashboards into code. And one of the first teams to do this were the site reliability engineers, or SREs. So the SREs, amongst many other things, had to run and maintain every single shard that we had in Atlassian Cloud. And I'm not talking about shard capacity like what we were looking at. This was the holistic application health of every single product that we had running on a shard. And so from an operational point of view, that was mental. I looked recently, and there are 286 dashboards defined just for Jira. And these aren't simple dashboards either. This is low-level stuff. Here's a very small subset of a very large dashboard where we see the number of threads consumed, the JVM heap consumption, and this is just a tiny part of one, and there's 286 of them. And then we have other products. It was insane. So a large part of this number comes from the fact that for every shard, we have about 5 or 6 dashboards defined. So now try to imagine if you had to add a new shard. And we do this quite regularly in Atlassian. You could go to the UI, and you could sort of manually create this dashboard and go and change it all. Or you could export everything into code, and you can use a template. So the idea with the template is that you move away from having a definition of a dashboard for shard A, shard B, and shard C, but rather a template for what you want that dashboard to look like, and then you can apply that template to your shard A, shard B, and shard C. And this isn't really possible without doing this through code. But I mentioned before that a lot of teams are doing this, and that's a lot of rework. You know, Atlassian's quite big, there's a lot of teams. And so one of my colleagues who was working on the shard service at the time, Sergis Sanika, figured, you know what, we can actually solve this problem at the platform level. So during one of our 24-hour hackathons, we set out to gather some data about how Atlassians were going about solving this problem at that time. And of the 91 service owners who responded to us, we found that 83.5% of them were still maintaining their operational resources through the UI, and some of these were quite large teams. We found that 67% of them were keeping their teams up to date of all these manual little clicky changes through the tried and tested technique of tribal knowledge. And 23.1% were actually satisfied with their existing process. And we had a quote from somebody, which we thought summarized it pretty well, but they said, "We've been saying for eons that we should put our monitors and dashboards into code. But the task is too big to start, and so we don't do it. Over time, the job just gets bigger and less likely to get done." And so we figured this was pretty compelling evidence. If we were to make this easier for people, it would have a real impact within the company. And so Sergis introduced the idea of Sauron, which was the all-seeing eye of dashboards and monitors. Sauron was basically just a microservice which knew about all the different tooling that we used internally and how to interact with their APIs. And that meant that as a dev, we could come in and say, "Sauron, go and export my dashboard." And it would go and find that dashboard for you, call the right API, and send you back whatever code you needed. That code could then be taken and put within your application. And then once you configured a webhook, every time you were to make a commit to that code, so if you were to actually change the dashboard or the monitor itself, that would fire an event to Sauron, and it would figure out whether or not it cared about that change. And if it did, it would automatically push that change downstream into the various different tooling. And that was pretty awesome, because it meant that we now had our code defined as the single source of truth without any need for bots to be set up or special API keys to be generated or even finding the APIs that we would need. It just sort of worked. And Sergis actually took this one step further, because he realized that now everything was defined in one place. And so for every service that was configured with Sauron, he exposed a UI. And that UI would show you all of the dashboards and monitors that you'd had configured. And so during an incident, you can go to this page and then see everything that you had, and it would link directly to that dashboard or monitor so that you can start debugging immediately. We found that this was actually a really, really good idea. And since then, over 50 services have adopted Sauron. And some of those are very small, just who are getting started, through to much larger teams, such as our most critical platform services and teams like Jira. And so how can you help your team keep up to date with change? Well, I'm not suggesting that everybody else out here goes and builds an entire platform service to solve this problem. It kind of depends on the scale of your organization. But no matter how many people work for your company, if you're not already doing it, I would strongly suggest thinking about exporting all of your operational resources into code. Because we found that this really helps drive the mindset that operational health is actually part of your definition of done and not a nice to have. Okay, so I've spent a whole bunch of time talking, so I just want to spend a few moments summarizing everything we've covered. To select what to measure, you really need to understand what questions you want to be able to answer with your operational resources. And that does require you to understand why your application exists in the first place and what failure means to that application. And with that, you can then ask yourselves how you can verify whether or not such a failure is occurring. And it is also worth noting it's important to understand how important your application is as well, because operational maturity is expensive. And so if you've got an application that no one's ever using, maybe it's not worth investing that much time into making sure it's 10 nines. To verify that you're measuring the right thing, you really need to just review those things, and you need to do it regularly. As your application evolves, you should expect your operational concerns to evolve alongside it. And to help your team keep up to date with change, we found that almost a quick win was to export everything into code. And we found that that really just helped drive that mindset of this is part of your definition of done. And it is worth pointing out that whilst all three of these things are great independently, we found them to have the biggest impact when they're defined all together. Because it's still going to be hard to figure out what to measure. It's not the easiest question to answer in the world. But we found that in having this, you can start with something. But then if you have this process where you constantly come back and review to verify whether or not that something is correct, and then you have this definition of done where your team all works together to try to iterate on this process as opposed to it just being one DevOps person's job, we found it was much more likely to eventually reach a point where you can call yourself operationally mature. Thanks. Okay, I think I have time for questions if anybody wants to ask questions. Yeah.
With so many applications, and then we having dashboards for every application-specific issues, then you will end up like with 1,000 of dashboards, and then within 5 years, 10,000 of dashboards. And I guess, yeah, we can maintain updating them, but would anyone would actually look at them? Wouldn't alerts be more useful?
So you really need both, and I think this is where the review process comes into play. So I mentioned one of the things we would ask is like, is this useful? So I think it's very easy to get to that point where you've got like one dashboard and it's this big and you only look at the first 2 panels. In that case, I think it's really important that the team collectively reviews that and there's an active, I guess, goal in trying to make sure that doesn't happen, because it's just a waste of everybody's time. And sorry, you said something at the end as well about the alerts, yeah.
Yeah, if you finish building the application, you hand off to like a support team. If the support team end up with like 1,000 dashboards, do they really actually constantly look at them?
Yeah, so I think the alerts side of things, I see these as being two, like very separate. So the alerts, I think, is the first point of contact, but then the dashboards should support the debugging of those alerts. So I see alerts as like a subset of what you would display on your dashboard, but that needs to be proportional. You can't have like 3 alerts and then, as you said, like 10,000 dashboards, because you're not going to know where to look. But for example, I mentioned errors. For example, we alert if we see a massive surge in errors. And so the first thing I would do is go to the dashboard to understand, okay, like where was the spike in errors? And then, for instance, like was there also a spike in latency at the same time? And then maybe that was due to CPU being super high. So like I feel it's as a proxy of what to go and look at, but it really does need to be reviewed a lot to make sure that doesn't get out of hand. Yep. How do we measure SLOs? Is that the question? It really depends on your service. So in our case, one of the services that we had was, for example, very low latency. And we had, have you heard of SLIs, like the service level indicator? So you basically identify things that you want to measure that are representative of your SLO. So in our case, you had this service that we had, I think we said it could never be more than 2 milliseconds P99 or something like that. And so latency was one of the core metrics that we would consider then. And so in that particular case, we had latency SLOs, we had availability SLOs, it was a 4.9 service. And I think they were sort of the main ones. But then you also have things such as data retention SLOs, like data loss SLOs as well. It depends, like if you've got really critical data, we had an audit service that we said the data would be there guaranteed for at least 24 months. And so we had SLOs surrounding that as well. And yeah. So the tooling that we use, we actually, for TechOps, we have a CLI tool that we've actually built. And so that will query all of the metrics that we have defined. Typically it comes from CloudWatch for SLIs and SLOs in general, unless you have something custom. And that has sort of automated a lot of it for us. So that'll pull that down, depending on what you've input as being your threshold, it'll calculate whether or not it was a hit or a miss. Yep. Yep.
So I know the usage is different. Did you end up monitoring the non-prod environments when you exported?
The non-prod, did you say?
Yeah.
So just in general, you mean, or just like across Atlassian, or?
Well, I guess yeah. Obviously, before you were exporting your code, you were just doing that in production, I'm assuming.
Yep.
But now that you can export it, you can monitor it in non-prod.
Yep.
Potentially you have issues before it goes.
Yeah, so again, it sort of depends on your application. Different teams have different structures for what non-prod does. Some teams, it does basically nothing because maybe it's not a really highly critical app. But in provisioning, for instance, we provision all of our Atlassian stuff, so things that we use internally, through the pre-prod pipeline. And so if we actually had alerts set up against our pre-prod, we had, basically prod was pre-prod, kind of, they were equivalent. And so all of the alerting and monitoring, we had very similar standards, except the thresholds were slightly different. And so, in that team we quite actively monitored it because they actually had Atlassian impact if we were to have messed it up. But in my current team, for instance, it's like a Slack notification if something pre-prod goes wrong, and then it's a higher priority if it's in prod.
Yeah. So I guess with your sharding service,
Yep.
obviously it scales differently in production, but you might want to be testing that out in your non-prod
Yep.
and setting up those alerts.
Yes.
So that you know, hey, the alerting does actually work.
Oh, sorry, you mean testing the alerting itself? Yeah, so we also have, so for Sauron in particular, we have this whole process where you have a test environment for your monitoring and your alerts and everything, and you have a test Opsgenie config and everything. So we typically work in the test environment for all of the alerting and the dashboards and stuff, and then once it's all good, then it goes through a PR process, and then it'll be merged to our production dashboard. Yep. Okay, any other questions? Cool, awesome, thanks so much.